So, good morning, everyone. Thank you for being here today in our tech demo webinar, Energy Web's Verified Compute. I'm Katerina Papapostoglou. I am from the National Technical University of Athens. We're partners of the InEExS project, and I will briefly present you about what is this webinar today. So the InEExS project, as you all know, is an EU project that tries to make energy services smarter and more trusted. So we use digital technologies to connect DSOs, aggregators, energy communities, and customers. And today we'll show how Energy Web's Verified Compute works within our project. We'll do a live demo with real use cases. And then we will have a simple look at our system architecture and how it's integrated. And we'll also show you some lessons learned in order to hopefully help other communities expand or replicate the solution. So here is the agenda. So we'll start with an overview of the project, and then we will, from Stratos Keranidis from DOMEX, and then we will have Kim Honorides from Energy Web do all these technical things about an explanation of what is the verified compute. We will have a live demo and some technical insights, and then the floor is yours to ask your questions and have a nice discussion. And some practical information. So first of all, during the meeting, please be sure that you have your microphone muted. If you want to ask a question, you can use the chat during the session, or you can raise your hand to be unmuted if you want to verbally, pose your question. And if you need anything, you can, if you have some technical questions, you can use the chat and ask Roberta, our colleague from ICP. Just to let you know that this presentation, this webinar will be recorded, and then we will make it available through our website. And yeah, let's start with Stratos Keranidis from DOMEX with a few words about the project. Stratos, you can go ahead.
Hello, good morning, everybody. I'm Stratos from DOMEX startup. We are heavily involved in InEExS. We are responsible for work package 3, which is the piloting work package. So in InEExS project, we have gathered a consortium of 12 entities. The project started in November 2022, and it completes soon in February 2026. And the focus is on developing and deploying innovative energy efficiency services through the power of blockchain. Next slide, please. So I will just give you an overview of what InEExS is. The core concept of the project is to develop integrated energy services across different sectors like HVAC management or EV charging. And across carriers, we currently employ 2 carriers, specifically natural gas and electricity. And the overall idea is that we tokenize all the energy savings and develop the collected data in a public blockchain so that we can enable third parties to get access to this data and verify their origin and the calculations. And we are very well coupled. Sorry. Previous slide, please. With the Energy Efficiency Directive and specifically Article 8. This is also the main focus of Business Case 3, which supports the obligated parties like energy suppliers to tokenize their energy savings and deliver them to authorities that are able to verify them. Next slide, please. So the specific objectives of the project are to conceptualize and develop business models and also contractual schemes. So we worked very closely with our legal partners to develop schemes that will be ready to be deployed in the field for the energy services. We also develop and validate the different technologies in the field, as mentioned in the different business cases. And finally, we managed to roll out a few of these services and also to replicate them across different, let's say, locations and different domains. Next slide, please. In this slide, we present the main intervention logic of the project. So in the first, let's say, development phase, we came up with the design of the business cases. Then we analyzed them, we collected requirements, we discussed with stakeholders of each different domain, and we came up with a business model that will be deployed in the real life. We collected feedback through the initial validation of the services in the field, and we redesigned and adapted the business models. And finally, with the, let's say, the final version of the business model and the technologies, where we are now in the phase that the services have been rolled out. We have managed to do replication for several of them across different domains, and now we have managed to collect knowledge from the field and adapt all the resulting end-to-end service. So all this intervention logic has been deployed across the 4 business cases of the project. Here we can see an overview of the architecture, the project's architecture. In the center, we can see the InEExS DLT platform, which builds on the Energy Web chain. And then we have the 4 business cases that connect through the chain and are able to offload their calculations and store them on the chain. We have 4 business cases. The first one employs a real estate company and an ESCO, and the idea is that they do energy efficiency renovations in buildings through the installation also of renewable energy sources. In the second business case, we have an energy cooperative and a DSO, and the idea is that they deploy smart meters plus renewable PVs, actually, a common PV that is shared across all the members of the energy cooperative. And through an app, we deliver data about their self-consumption improvement. In business case 3, we provide a solution that is a smart thermostat. It is deployed both in gas boilers and electrical heat pumps. And we have a collaboration between the energy supplier and the technology developer. And finally, in business case 4, we have a collaboration between, again, the energy supplier and the technology developer. And the solution is a service that improves the optimal charging for EVs through different incentives. So this sums up the 4 business cases, and we have also a 5th one, which is at the conceptual stage. And the idea is that this business case, please, next slide, please, is developing a decentralized energy efficiency power plant. So this one has not been integrated with the actual architecture, but the requirements have been taken into consideration to develop the overall approach. So this is the intro for InEExS project and the 5 business cases. So I now pass the floor to our partner, Kim Honorides from Energy Web, to present you the overall technical approach. Thank you very much.
Thank you, Stratos. So, Kim, you can share your screen.
All right. Good morning, everyone. Can you see my screen?
Yes, we can.
All right. So, hello, everyone. I am Kim Honorides from Energy Web. I am the solutions architect for the decentralized enterprise compute on the Energy Web X chain using worker nodes. So today, my team and I are here to present the worker nodes in action, powering the InEExS use cases. And for our presentation, we are going to show you how to deploy the worker nodes in your enterprise environment, as we did for the InEExS partners. We will provide a high-level overview of the architecture of the decentralized worker nodes, in relation to our EWX chain, and also show you some of the live workflows and data flows that are running on the worker nodes. And hopefully we will have enough time for Q&A and also to gather more feedback from you guys. Yeah. So the InEExS project currently that we are involved in has 5 business cases, and we are able to apply the integration with the blockchain for the 4 business cases that we have worked with. So these are the 4 business cases, and we have integrated our EWX chain. Energy Web has currently has 2 types of chain. Our legacy chain, which is EVM-based chain, is called the Energy Web Chain, EWC. And EWX is our newer version, which is substrate-based on Polkadot. And having EWX as a backbone for the integration, we built on top of it the EWX worker node networks. And this is for us to have an environment with trust, security, and also auditability for the data involved within the ecosystem. Just a little bit of recap on what a worker node is. So a worker node is a single processing unit that can execute enterprise calculations, submit the votes on-chain, and derive consensus-based results in order to get more transparent and auditable data. And so this is how it looks like at a high level. We have a worker node that would fetch, that would install smart flows. These smart flows are the definition of the business case logic. And then it gets executed inside the worker node. Once executed, the smart flow has the ability to fetch raw data from different data sources. It could be inside the enterprise itself, or it could be an external data source from the enterprise, such as devices, etc. Once the raw data is fetched, then the smart flow would be able to calculate the results based on the definition of the business logic. Example of calculations would be to calculate daily efficiency or daily consumption of energy for a particular household. So that could be one of the calculations involved in the smart flow. After the calculation arrives at a result, then the result is hashed using the Merkle tree root hash calculation. The Merkle tree root hash would then need to be submitted on Energy WebX, our blockchain. So it is not the raw data or the computed data that gets submitted to the blockchain, but the hash of the result of the calculation. So once the result is already exist on blockchain, then the worker node will calculate or check if the consensus is reached. So what does it mean? There will be multiple nodes that run potentially the same calculation. And in order to arrive at a consensus, all of these worker nodes need to have the same result. So the same calculated result and also the same root hash. If all are the same and a consensus is reached, then the worker node will forward the consensus-based results. So consensus-based results contain the actual calculated data, the hashes from chain, and also the metadata of the consensus. And these consensus-based results can be forwarded to the business case or enterprise, or potentially any party that is nominated by the enterprise to receive such data. depending on the configuration of the worker node and the smart flow. Another portion of it is the auditing of data. So for example, an external auditor would want to prove that such data exists and that the computation is correct. What they can do is to first to have an access to the raw data, right? And then calculate the result as an auditor based on the defined calculation formula, and then calculate the Merkle tree root hash. The Merkle tree root hash is a standard root hash calculation that is available, readily available. And then if the auditor has the same root hash compared to on-chain hashes, then it means that the raw data plus the calculated data as well as the logic involved is correct. So then we have a transparent and auditable results. Yeah. These are the smart flows. These are actual smart flows of the business cases that we have deployed. Some of it are already deployed on the production environment. So for example, we have BC1 from BEA, which is the solar quota. We have BC2 from Enercoup, which is the monthly energy consumption, energy savings estimation for DOMEX, and then BC4 smart charge savings. These are just one of those smart flows that are developed in each of the business cases. And we are using Node-RED technology for this in order to wire the nodes that are logical nodes and to form and define the business logic. Yeah. So one set of this is one business logic computation, from fetching of raw data, computation of results, submission of results on chain, and then checking for consensus, and then relaying the results back to the business case. And we are always asked about what data is stored where. So for on-chain data, what we are storing in the blockchain would be the business case and smart flow metadata. Example of this is the name of the business case, the smart flow names, etc. The business case, the smart flow associations, the operator and worker associations, the subscriptions, and also the result hashes. And the off-chain data would include raw data, calculated data, a copy of those result hashes, and the consensus metadata which were relayed back to the business case. And the off-chain data is responsibility of the enterprises themselves. So the off-chain data need to abide by the data privacy policies of the particular enterprise and also asset if there is a consortia based on the consortia policies. The worker node at a high level has external dependencies. These include the CDN, which will provide the dynamic and non-sensitive worker node configuration files. We have of course, our blockchain. We have IPFS, but for the InEExS project, we did not employ IPFS. This is a decentralized file storage system, but since the BCs would want that the data would be private within their private networks, so we opted for the private storage of the flow files. We have the authentication server and also the worker registry server, which are essential to register the worker node in the worker node network environment. And this one is the other systems which are inside the enterprise itself. So it could be their let's say, for example, API services, their batch processing systems, and many others. So this is within the enterprise environment. And our common setup for the business cases would be 3 private worker node servers deployed in each of the private networks of the enterprise. And in order to deploy the worker nodes, these are the prerequisites that are involved. First is that the business case smart flow is created. So the business cases, the 4 business cases that we have interacted with, have developed the smart flows by themselves. They have defined their business business cases themselves. And then after that, those business cases are exported into files and then gets registered on the Energy WebEx blockchain. Then we have also the operator and worker accounts, which are essential in configuring the worker node server. The worker node account is a prerequisite for the worker node server, and the operator account is required in order to to be whitelisted into the enterprise business case. So this is the portion to whitelist. And a typical smart flow has these 7 processes. First is to trigger the smart flow. This is the schedule as to when the smart flow would execute. Fetch the raw data, calculate data, and then calculate the Merkle tree root hash, submit the result to the blockchain, check the consensus, and then relay the consensus-based results back to the enterprise. And these are the business cases that are already present in the blockchain of Energy WebEx. So these are live on production. These are the extrinsics and the chain state. Extrinsics are the functions on the Energy WebEx blockchain to create and register these solution groups or the business case groups. I would not show this now because we will need more time for the actual deployment process. And then these are the solution groups as the solutions or the smart flows that are registered now on chain in production environment for each of the BCs. So this is for BC1, BC2, 3, and 4. These are the functions on the Energy WebEx blockchain to register the solution, the smart flows and associate with the business cases. So this is the operator account. Mainly, it represents the user itself. It holds funds to register as operator, subscribe to the business case, and then if it is enabled for other business cases, let's say, for example, if the business case would want to opt in for a public or semi-public, or let's say, for example, nominated kind of worker nodes processing, and then they would want that these operators would have rewards by running the workers themselves, then rewards can be enabled as well. For the worker node account, this proxies the operator. It will never hold funds, and it submits results on chain. So the separation here is very clear. The worker account is only responsible in the submission of results, and the operator account is the actual user account. And this is how it would look like on chain. This is our explorer, the Energy WebEx blockchain explorer. That shows that BC3 DOMEX has 3 worker accounts whitelisted in the private business case. I will not show how to do this, but yeah, this can be shown on the Explorer. And now I would proceed with the deployment of the worker node server. There are two options that a business case or an enterprise can deploy the worker node server. First is via the EWX Launchpad. This is a platform in Energy Web that the user can just go there and spin up the worker node through a service. And another one, which is preferred by all business cases in the InEExS project, is self-hosted. So the BCs will host the worker node server in their premises that complies with their own company, network, and security policies. And at this point, I will hand over the floor to Chris. He is our lead developer for the worker nodes, and he will show us how to set up the deployment configurations and execute the deployment itself of the worker node. Chris? Hello, test, test. Chris, are you here? Huh. Maybe you can show your screen if you are. Wait a moment.
Yes,
Let me...
1 second. I will
Well-
give the.
We will make him a speaker, Kim. So wait a second.
Hi, everyone.
Normally should
Yeah,
work. Yes. Yeah.
thank you for that. Hi, everybody. My name is Chris. I am lead developer on the worker node project. So I will share my screen right now and give you a presentation about the worker node setup. I hope everyone can see my screen.
Yes, we can.
Yes, yes.
Okay, thank you very much. So what I will do, I will start by explaining you the configuration, how it's configured, and then proceed to a live demo, how it works. So first of all, we have a Docker Compose, which is our architecture, our configuration, how worker nodes will behave, with what they will communicate. So yeah, let's go step by step. First of all, we have set up a 3 worker nodes, and 3 is our minimal number that we need to proceed in the worker node network. Why? Because we are working with consensus-based results, meaning that for the consensus, we need to have the majority of worker nodes need to agree on some result. So that's 3, because when you have 1 or 2, we cannot agree on the result, who is right. And we have 1 server, which is going to be delivering the data for the worker nodes for their smart flow. And they will also receive the computation result of those worker nodes. So as you can see, I have set up the local JSON, which is the smart flow that all business cases were implementing. Inside of this JSON file, we have some key, we have some ID, we have some label, but we have the nodes. Nodes were developed by by BCs and us. They handle the business logic, how the smart flow will proceed with the data it receives. Moving forward to the specific worker configuration. So I will go very quickly over each of the values to explain you how they work and what is the purpose. So we have the excluded nodes. This is implemented for security purposes. We don't want any nodes that have too many permissions to be executed. For example, exec nodes that can execute bash commands. We have some internal flags for retrying the checks of the worker if the worker is configured properly, otherwise you cannot start the worker on server. We also have the health API if We want to see if the worker is healthy. We have the configuration to which RPC we want to connect to. This demo will be performed on the testnet, not on the mainnet. Every BC right now is on the mainnet instance. We have a port, we have the host, which are used for communicating with the Node.js UI. We have also Node.js UI enabled, where we store the Node.js data, where we store the SQLite data, how often we refresh the data. Heartbeat is for the worker node to give information that they are alive. We have our workers registry where we register every worker. We have the authorization server, the base URLs, which are the indications for the workers, how they want to communicate with services. Some logging flag, if we should print it pretty or not in the console, where we store our smart flows, and the most importantly, the worker seed. This seed in general needs to be stored securely. No one should have access to it. But since I am demoing for you and this is on the testnet, I don't really mind if this worker seed is exposed. But in general, the good practice is to make it hidden through some environment variables, maybe through some secrets engine. So that would be our configuration. Let me proceed to give you an overview of the flow. So this is how most of the business cases smart flows looks like, as you could see from the Kim screenshots. So there are parts that were the BCs were responsible for, and there were parts where I was responsible for development. So every time you see the prefix AWX, this means that it was developed by AWX, but other parts are implemented by the business cases. So the flow, usually, it starts at specific interval defined by each business case, by their business use case. So it could be every 24 hours, it could be every 6 hours, depending on the use case. So first of all, since it's a demo, we have some get random data, which is going essentially to return us an element with random value, with random number. Then we have a prepare function call, and this is where the most business cases would put their logic to calculate daily estimated energy savings, let's say. And after that, InEExS is going to try to submit a vote. It will try to calculate the hash of the computation using the Mercury root hash algorithm. It's going to be submitted on the InEExS, and then we await consensus, which is the most complex part of the smart flow from the InEExS perspective. So we are going to await for every worker to submit their vote, and we are going to check if we reach consensus, if majority of the worker nodes voted for some specific result. Once it happens, then we select the leader. The leader is going to be one of the workers, one of the 3 workers in that case, that is going to submit the data to the system, to the end service. For example, it could be an API endpoint of your application where we send the calculated estimated energy savings, where we submit several important data, which includes the consensus transaction hash. It shows when the consensus was calculated, when we have the result. We also store the Mercury root hash for further for confirmation of data processing. This can be used later by auditors to confirm that this data was indeed created using this smart flow, calculated using this smart flow. So let's start with the live demo. First of all, I will run the Docker Compose app, which is starting out of the services. As I explained, we have the 3 worker nodes and some server. It will take around 30 seconds, maybe 1 minute for all of it to complete, to start the, I'll make it a bit bigger, to bootstrap and all of that. But I can already start refreshing the instances. Yeah, they are loading up. So normally what would happen, the smart flows would run at specific interval, as I explained before, like in every 6 hours, every 24 hours. But for the demo purposes, I am going to run all of the computation at the same time manually to save us some time. So right now I am starting the flows. And as you can see, we already fetched some data, which is some random value. We have prepared this data for further Energy WebEx computation that is going to calculate the Mercury root hash and so on and so forth. So let's go back to the logs. And as you can see, we are receiving a message that there are not enough votes because Energy WebEx is a substrate-based Polkadot chain, and we operate in blocks. The blocks are created every 12 seconds. For the demo purposes, I set the consensus time to very minimal of the 4 blocks, which should be around 1 minute, depending on how performant is our testnet right now. So we need to wait around 20 to 30 seconds, I believe. Okay, so I have already some transaction hashes calculated by workers. I have the calculated Mercury root hash. We are already done with this part, and I can see that the workers submitted their votes. So I can copy that and visit the testnet environment. So right now I am heading to the Explorer, and I'm going to paste the transaction hash of the vote. From what I can see, I have already 2 votes submitted by the workers. So I guess the third vote is in the next block. We have the demo next sol 1, which is the name of our solution for the testing, right? We have also here one of the vote submissions. And right now we need to wait for the reached consensus node. And from what I can see, we already reached the consensus. So let's query our system to see the consensus result, the submitted result. Let me head up to the requests. Query. Okay, we received some details from the system. We have the leader address, as I spoke before. We have the result hash, which is the hash of the computation. And we also have the consensus transaction hash, which is the most important for us to confirm that the computation was performed. Submit, and it's the same as we had with the vote submission, because this points to the place where worker submitted the vote with the Mercury root hash. So let me find this voting round for the solution. So I can see that our voting round, the voting round is a concept where all workers participate to submit, to run some calculations. This is like a temporary container where the workers submit their vote. And I can see that there is a result. So this is the result of our computation. The worker agreed on that because we received voting round settled. So I believe that would be everything from the technical demo. We went through the configuration, the initial setup we had, what is the configuration. We went through how SmartFlow looks like, and we went through the whole presentation from the start of the flow to the end of the flow.
All right, thank you very much, Chris. Let me share my screen. All right, so Chris has shown how an enterprise would be able to deploy their own worker node server. Now, at this point, I will show, these are just screenshots, but these are actual execution of business cases for one of our BCs. This is under BC1, BEA, and because they have their own custom use case definition, so they have their own smart flow, and this is how it looks like for them. So they have 3 worker nodes deployed, and each of them were able to submit results here. And then node 3 was able to check for consensus that it has reached, but worker node 3 is not nominated as leader for that. However, the one that was nominated as a leader for that voting round was worker node 2. So it has this entire consensus data. So this is the consensus, this is the voting round where the votes came in. This is the consensus hash that confirms, or the block hash that confirms that the below calculated data is correct. So this is the actual computed solar quota that was executed for that specific time. And this is so we can check this on chain. This is our, so I have already pre-copied that one. This is the block where the consensus happened. And then you can see here, if you see these red marks, this is not related to the BC1 solution, but this is for the other solution. So this is under the SAFC solution, which doesn't meet our result at the moment. So we are only looking for the BC1 solar quota, and they have 3 workers that have submitted the result. And these are the results. So if you look at the end, right, these are all the same, meaning that the consensus has reached because they have the same result. And this is the public key here represents the worker, the identity of the worker that submitted the result. So these are all different workers under BC1. And this is the consensus. Let me see if I can go back to the right. And now it's time for Q&A. So that ends our presentation for for showing how worker nodes are deployed in individual enterprise environments. At this point, we are open for questions and feedback for this event. Thank you.
Thank you very much, Kim, for well done. And Christopher and Stratos for the nice presentation. And yeah, let's see if we have any questions. You can put the questions in the chat, or you can directly raise your hand and we can unmute you. Okay, I will give you 1-2 minutes to think about it. Are we planning, Roberta, are we planning to share the video through our channels, right?
Yes, of course.
Okay, and we can prepare some key takeaways from this webinar, shared through our media and web page. In the meanwhile, I don't see any question or comment. We have. We can. Let me unmute. So you can go ahead, Francisco, unmute yourself and ask your question.
Thank you. Good morning. Thank you for the presentation. It's very nice to listen to you and this very clear explanation about how it works. So thank you very much. And my question would be, because we have been working in this InEExS project and the Energy Web platform for more than a year. And I think that from the start of the project until now, there have been some, let's say, changes and improvements and maybe learnings. I don't know which is the right words or the right comment, but clearly we have been learning and we have been working together, and things have been, let's say, improving in the project. So according to you, can be a question for anyone, and maybe for Kim that has been longer in the project. Uh, how do you see the difference between when we started the project about this integration and the platform, between the start of the project and the day up of today? So where did we find, let's say, where did you find the main barriers for the developments and integration with the systems of the partners? And which has been the learnings for, let's say, future projects, considering that this will be finished soon somehow, and we will be able to replicate or to develop other projects.
All right. Thank you so much, Francisco, for that question. So we have few learnings during the course of our integration with the BCs. Each BC that we have worked with has quite unique set of people. They have their own unique set of skills. Some BCs are more technical than the other BCs. But other than that, one of the challenges that we faced previously was in terms of the authentication of the data source endpoints. So because one of the BCs actually require external data source that need such authentication strategy. And we had three. So we during the course of the discussions that we have, what we learned is that there are potentially few options to do the authentication. So one is either the authentication sits in a system within the enterprise itself, or the authentication can be done through the worker node itself. But because there is like it also depends on the authentication strategy, but for this particular data source, it requires for the authentication to happen at a particular system, and then the data is fetched by the system. And so then the authentication between that system and within the worker node itself is through the within the network authentication between the internal system and the worker nodes itself. So that was one of the setups that we did for this particular challenge that we had for the authentication. We also have one of the items that we have got some challenges is that how the BCs can actually implement their business logic through the smart flows, because some BCs have specific technical capabilities, right? Some are not savvy in terms of let's say the Node-RED itself, and also with JavaScript. So what we did is that there are BCs who have their computations sit outside the worker node itself, but then it pulls out the data from the computed data from their systems, and then after that use that computed data to feed into the Merkle tree node of Energy Web so that the Merkle tree root hash can be computed and then submitted to the blockchain. So that's also one of the takeaways that we did for one of the BCs. And with that, we were able to speed up the creation and the deployment of the solution itself and integrate with the blockchain. Maybe Victor and Daniel, because they are here, they are the main developers for their own BCs. Maybe they also have some takeaways from the integration with the worker nodes. Victor, Daniel, do you want to say something? I don't know if Victor and Daniel have access to the microphone. though.
I can. I'm trying to find them in the list and unmute. It's Daniel, right?
Yes, Daniel and Victor.
Okay. Daniel has been given access, and I'm trying to find Victor in the list.
Yeah, I have got the
I've
access.
already,
Can you hear me?
I give, yes.
Yes.
Yeah, thanks. Maybe, yeah. So it was challenging to integrate the blockchain. Yeah, but at the end of the day, when the technologies has been set, I mean, not red and the KPI calculations, then with help from Kim and Christopher, we at the end managed to integrate it. And yeah, you have seen the screenshots of the consent and hash. So it basically works in a way as it has been described. I think it's a lot of new information for the ones who are new here. But for instance, I think it was also not a milestone for Energy Web to integrate this off IPFS integration, because we got the possibility to modify our smart flows locally, which was really helpful to change them sort of in real time, for instance, to get a better messages or to change the ports or to access a different API that calculates our KPI within the use case. Yeah, and this is a little bit confusing because one needs to bring a lot of different technologies together. But at the end of the day, it's worked. And the key point was to stick to a HTTP exchange and to follow the instructions and get help from the people who knows how the blockchain works. Yeah, and what also was a little bit time consuming is to create these accounts and to connect them. I don't know if Kim have mentioned that, because you have seen that during the presentation there is connection of different worker nodes, and each worker node requires its own seed, which is sort of private key. And this was a little bit challenging to get it right, and without help from Energy Web, it wasn't possible. Yeah, to do that, I think, because we had a couple of appointments to do that, because I'm not the only one who is involved. There is also Franziska online. There is also other people from Berliner Energieagentur who are involved, who are in charge of data gathering and business case definition. I'm just a technical person who is helping with technical implementation. So if you have any questions regarding business case one, technical integration, you just free to ask them.
Thank you so much, Victor, for that. Daniel, do you want to add anything?
Hello, everybody. Yeah, we can speak about our experience working with all the energy web ecosystem. What we wanted to highlight here is that from the beginning, the way in which you want to, or you can, or you need to deploy your service is very flexible, because Energy Web, they offer you the possibility of have everything hosted like in your own premises, but also it can be like hybrid deployment, because they can support that. And we found that very flexible. I think that in our project, in an InEExS project, almost everybody took the option of doing it on premises, I think. And at least our case was that one. We have everything on our premises because the data because of the data that we are using, it's GDPR data, has to be anonymized. So that helped to maintain regulatory compliance. Then they have also all these worker nodes, and this the technological part is you can Dockerize it. They have the image, so it's very easy to pull the image down and have everything installed. Like in not too, you don't have to spend too much time setting up all the infrastructure. What actually takes more time is configuring it, okay? But you can find your worker nodes and all your pieces or your blocks that you need for the blockchain in a fairly short amount of time. Then, as Victor said, the DLT part is you need help from them, because but it's only because it's DLT blockchain. It's a technology that if you are not working constantly on it, some concepts or how does it work, or there's different chains, different currencies, communications is not easy for someone that doesn't work with that in a normal basis to pull the configuration in one shot. You need help from them, because because it's not an easy task. Also, there's a part, as Victor said, the part of the configuring the accounts. If you don't have a profound or at least a minimum knowledge of how blockchain works, sometimes you're wandering around without knowing what you're doing. Also, you have to take into account that all this works. You have to blockchain transactions pay fees, so you need to have some balance in your accounts to be able to do all these operations that Chris and Kim showed here before, because operations in the blockchain cost a fee. And then as the developing part, the part which each business case had to work on was mainly on the Node-RED part, which is where you configure your smart flows, which are the logic. The business logic is embedded in the smart flow, and it's Node-RED. It's I don't know. I think it's flexible. I think you can see very well what you are doing, and from the perspective of the implementers or the programmers or the developers, you have to use only one language, which is JavaScript in this case, and the business logic you have to put in some specific place, so it's easy to implement in the sense that you know where you have to put it. Other thing is how difficult your business case or your operations are. Some people have to do API calls from outside Node-RED. I don't know, some authentication, as far as Kim said. But there's a complication from those complications come from the logic or how you're setting up your case, not from Node-RED itself. It's true that Node-RED, being a graphical interface, it's not, sometimes it's a little bit difficult, because you have to understand first Node-RED to be able to do some things. But in the end, everything comes to a good ending. I don't know if anybody has any questions about our business case or whatever, but we're happy to answer them.
Yes, Victor.
Yeah, I just want to add further. Yeah, not red. This was a little bit confusing as a technology to implement our business use case. Why? Because we have a bit complicated data structure behind it. That's why we have to switch not from Node-RED, but this KPI or data gathering have to be done in different programming language. It was Python in this particular case, but as I told you initially, the glue that we use to glue all the moving parts within the blockchain integration was HTTP. So it's basically a node thread that had to call the APIs and had to call multiple APIs. And behind each call, it was a different computations that has been hidden behind it. So that's how, despite having a single language like JavaScript to do the smart flows, you could also, so the solution is flexible enough to support also other languages, programming languages, when you are like sort of gluing everything using HTTP, then it works. Yeah, just like a small hint from me. Thanks.
Thank you very much. And I think that if we don't have any other comment, we're 2 minutes after the end of
Katerina,
yes, Francisco.
One last
Your
question.
last comment. Yeah.
I was wondering, with all these experiences, if we develop a new project, let's say, imagine we start the project now. Also, this is, I think, for Kim, also maybe the question. If we have to start the project now again, and we will do it a little bit different and more optimized, what would be, just to estimate the effort done, okay, or to be done, what would be the number of, let's say, hours that Energy Web has to dedicate per average business case? So how many or days of work altogether from all the people working in Energy Web, let's say?
All right.
An estimation, let's say, an estimation, rough estimation.
Yeah. So for the deployment alone, right? So it is quite subjective as a question, because it actually so all of this depends on the technical capacity of the business case. So for example, if the business case is well equipped with the technical skills to deploy, the worker, I would say, deployment alone, I'm not talking about the creation of the logic itself. Yeah. I think it would take a week or 2 or even less to do the deployment, right? But for the creation of the business case, it all depends. I mean, the smart flow itself, it depends on the BC, and this is the part that took a lot of time, and is the most time consuming for all of this. Deployment is very less, but really the development of the smart flow takes more time, depending on the capacity of the BC itself.
Of the BC. Okay, if you have to work, for example, just to be too specific, something with Daniel, for example, that now has some experience, we develop another one.
Yes,
in Spain,
for Daniel. Yeah, for Daniel, actually, it took. I would say for Daniel, if a simple business logic will be involved, a week or 2 is enough to create. I believe so.
Okay.
Yes.
And the time needed, for example, Daniel, if you just to be, to prepare kind of cost of the situation or effort of the situation, what would be the time you needed for you have to develop a new one? How many days of work?
You mean if a new project starts today, how many time I would need to do the same thing I did?
Yes, correct. Now with the experience you have, let's say, it's just to compare with the situation for the future, for replication or something.
Okay, now having experience that what I have done, and Kim knows that we faced even an internal change of technology there in Energy Web. Knowing with the experience now we have with blockchain that we didn't have when we started the business case, with the experience in languages and how the architecture of Energy Web works, knowing that, don't have to spend time in researching and understanding. It will be a matter of days, like Kim said, maybe a few days only doing that, implementing the business logic. You have to take into account that you have to have a clear vision of what you want to do. If you don't know what you want to do, you can spend a month. But if you know what you want to do and you understand the technology, if the blockchain part and the infrastructure part of your partner, in this case, Energy Web, it's a matter of days.
Okay, like something like 10 days, for example.
Yeah,
it's a little bit hard for me to say, because it depends on what you're trying to do. But if it was our case was gathering measures from EnerCube users and making some calculations in order to feed back to them a way of making more efficient use of energy. That is like we think that that's not a very complicated business logic. So that would be a not complicated business logic. Maybe it's less than a week. If you get into a more complicated with more KPIs, more calculations, more data crossing, whatever, it perfectly can take up 2 or 3 weeks, even a month.
Okay. Perfect. And one last question to cover everything. What would be the cost of the platform, Kim, more or less for the use, like for the case of EnerCube? If now next year, let's say they would like to continue with this, what kind of cost does it have, the energy web platform? Because I think it's something we didn't discuss and we don't know really if next year we want to promote the platform and work with you after the project ends. What is the cost of this, of the use of the platform or your support? I don't know, how is it?
Currently, I don't have the numbers, right? I can get back to you on that.
Okay. Do you know more or less a range compared to, I mean, in other projects, which is the range of this service? I mean, you can come back, of course, but some estimation like 2,000, 10,000, 50,000. I don't know the range.
I don't really have an idea
Okay.
current. Yeah. Maybe,
Okay.
yeah, maybe Ivan has. Yeah. Ivan is not a speaker, so maybe need to provide microphone access. Thank you.
I did it.
Hi, good morning. Can you hear me?
Yes.
Yes, we can.
Yeah. So the cost is a complex issue because it really depends on. So there are different things to pay for, and it really depends on the setup, right? So with some of the customers, we made a complete custom deployment in their systems with support, maintenance, their own worker nodes. So that has a cost, right? And if somebody takes our technology, set up their own worker nodes, link it, develop their own smart flows, and they do it by themselves, that has a different cost, right? And then there is what we call the gas fees, right? What you have to pay for each of the computations in the worker nodes. So every time, every person that is running a worker node gets a certain amount of rewards for running the calculations and submitting a vote. And that again, that depends. Like, are you running your own worker nodes? Then you're getting paid for running it, right? Or are you running it on the public network? Then you have to pay for those gas fees as well. That is not much. That's in the scale of cents of euros. But if you keep it running for years, that's a cost that you have to account in your business, right? So it's really variable, and it really changes from case to case. Like, how long does it take to deploy? What kind of maintenance you want to have afterwards, or support, right? And do you want to have access to the updates or not? And we are a startup, a small company, so we are pretty much at this moment tailoring it for each case and each customer. So I cannot give you a figure, right? But if you think about the license support and maintenance, or any software as a service that you can find online, that will be pretty much similar where we are moving on right now. I'm sorry we cannot be more clear, but it's really a case-to-case number for us at the moment.
Okay, thank you.
Okay, I think that that this is it. So I would like to thank you all very much for being here today, discussing all these interesting things, and we will get back to you with the key takeaways and the recording of this event. Have a nice day, and thank you again very much. Goodbye.
Thank you.
Thank you so much. Bye-bye.
Thank you.